We looked at our original ratios of sine, cosine, and tangent, but we also have their reciprocals. Now remember that reciprocal just means that we are flipping it. So yesterday, remember sine is opposite, sine of theta is opposite over hypotenuse, cosine of theta was adjacent over hypotenuse, and tangent of theta was opposite over adjacent. So we have three reciprocals as well. So instead of having opposite over hypotenuse, we have hypotenuse over opposite, which is the same thing as saying it's 1 over sine. Remember, we say sine, but we write sin. Okay. The reciprocal of sine we call cosecant, and again we abbreviate with 3 letters, but you can't abbreviate cos because that would mean cosine, so we do CSC for cosecant. Okay. So our cosecant's the same thing as the hypotenuse over the opposite. The secant is the reciprocal of cosine. So instead of adjacent over hypotenuse, we flip that, and the hypotenuse goes to the top and the adjacent goes to the bottom. So our secant's the reciprocal of cosine, which is saying the same thing as 1 over cosine. And then we have our cotangent, which is the reciprocal of tangent. Tangent was opposite over adjacent, so the opposite goes to the denominator and the adjacent goes to the numerator. So that's the same thing as saying 1 over the tangent of theta. So let me show you the long way. If we have the tangent of theta, remember the tangent is really opposite over adjacent. So if we have a complex fraction, that means that we'll flip and multiply. So I times by a over o, which then this disappears because we flipped and multiplied. So 1 times this a over o is just the a over o. So this is how 1 over tangent's the same thing as the cotangent. Okay. Now the way that I help myself remember is based on the letters. So we've got cosecant starts with a C, and its reciprocal starts with an S. So secant starts with an S, and its reciprocal starts with a C. So the C's and S's flip-flop. You do have to realize that cotangent starts with a C, but it matches with tangent. Cotangent and tangent sound like they should go together, and they do go together. Okay? So that's how I help myself remember. It works going the other direction. So if sine starts with an S, then its reciprocal starts with a C, so it's cosecant. If cosine starts with a C, then its reciprocal starts with an S, which is secant. And then tangent sounds like it should go with cotangent, and it does. So that's how I help myself remember. Okay? And that whole thing is right here for you. Okay? So now all we're going to do is find our reciprocal ratios. So here we've got to label our triangle just like we did yesterday. So we find the hypotenuse, which is across from the 90-degree angle. And then we label from our angle that we're looking at. So in this case, it's this angle. That's our theta. Remember, that's just a variable. It's a Greek letter. So across from there is the opposite. And then this is the adjacent. So if we want the cosecant is the reciprocal of, it starts with a C, so its reciprocal starts with an S, so it's the reciprocal of sine. So sine is so, which is SOH, so sine is opposite over hypotenuse, so that means that the cosecant is going to be hypotenuse over opposite. So I want the hypotenuse and the opposite. Well, I don't have the opposite, so I have to use my Pythagorean theorems to get to the third side. So this is our hypotenuse, so we're going to have 23 root 2 squared equals 23 squared plus some other number squared. Okay. Remember, you can move the 23 squared to the other side. So I subtract the 23 squared to get to b squared. So we can put this in the calculator. So if we go to the calculator, we've got 23 square root of 2 squared minus 23 squared equals 529. I'm going to see if 529 is a perfect square. It is, and it gives us 23. So then b squared equals 520 something, 529, which when we square root, again, we don't have to do plus or minus on this because we're in distances, so our distances are positive. So now I'm going to get the hypotenuse, which is 23 root 2, over the opposite, which is the 23, The 23's can cancel, so we get root 2 as our answer. If we look at this one over here, we again need to label our triangle. So across from the 90-degree angle is the hypotenuse. Chuck a ball in the angle you're sitting at, that's the opposite. This is the adjacent. Okay. Secant starts with an S, so its reciprocal starts with a C, so its reciprocal is cosine. Cosine is some old hippie caught another hippie, so AH. So I'm looking for the secant of theta is H over A. I have the H and I have the A, so I don't have to find this third side. So the H is 20 and the A is 16. So we reduce. Remember, you can reduce in your calculator. You can either do 20 divided by 16 and then hit to the right of the 1.25, that circle box, and it will change it. Or if you are in a TI calculator, you can do, I forgot what the numbers were, 2016. Math, which is the third button down on the left, and then enter on frac, and then enter again, and it will switch it to 5/4 for you. So this gives you 5/4, wrong spot, or you can reduce by hand. If we look at this one, we've got the cosecant. Again, we need to label our triangle. So this is hypotenuse, this is opposite, this is adjacent. Cosecant starts with a C. Its reciprocal starts with an S. S goes with sine. Sine is scat o hell. So we need to flip it. So we have the H over the O is the cosecant. So I need the hypotenuse. I don't have it right now, so I have to find it using the Pythagorean theorem. So I'm going to do 2 root 14 squared plus 5 squared equals c squared. So we can do 2 root 5, get out of the root, square it. Nope, 2 root 14 and 5. So that gives us 81. So we've got 81 equals c squared. We take the square root. Again, we don't need plus or minus because we're talking about distances, and distances are positive. So now this gets us, our c value is 9. Okay. So I go back and I look, my cosecant is the hypotenuse over the opposite. So the hypotenuse is 9. The opposite is the 2 root 14. I look to see if I reduce. I cannot, but I don't want this root in the denominator. So I'm going to times by 1, but it's a very particular number 1. We're going to times by root 14 on top and bottom. So this gives us 9 root 14 over 2. Don't forget about this 2 that's right here. And then root 14 times root 14 is just the number 14. I can look to see if I can reduce anything here. I cannot. So I just multiply. So 9 root 14 and then 2 times 14 is 28. Again, you can double check here and see, can I reduce there? I cannot. So then this is my answer for the cosecant. If we look at our last option, we've got, this is our triangle. So I'm going to label across from the 90-degree angles the hypotenuse. Stand here, chuck a ball that hits the opposite. This is the adjacent. Cotangent sounds like it goes with tangent, so it does. The tangent of theta, let's see here, the reciprocal is tangent. The tangent is opposite over adjacent, so we want adjacent over opposite. So we want the opposite and adjacent. Opposite and adjacent. I don't have the adjacent. Now, if you remember your Pythagorean triples, you know that this is 7, 24, 25. If you don't remember that, then you have to do 25 squared equals 7 squared plus b squared. So you'll subtract the 7 squared to the other side. So we can do 25 squared minus 7 squared equals 576. If we take the square root of that answer, that gives us 24. So either way, you get that you end up with 24. So this side is 24, so we're wanting the a over the o. So the cotangent of theta is the A over the O. The A we just found was 24. The O is 7. I look to see if I can reduce this. I cannot, so then I'm all done. And that's how we use our original ones to help us find our reciprocals.